You have seen this error. Red text in the console, usually at the worst possible moment, during a live demo, right before a deadline. Access to fetch has been blocked by CORS policy. And here is what most developers do. They panic. They Google it. They find a Stack Overflow answer that says, add access control, allow origin star to your server. They paste it in. The error goes away. They move on. And they never actually understand what just happened. Or worse, they just opened a security hole they do not understand. Because here is the thing about CORS. It feels like the browser is fighting you, like it is a bug you have to work around. But CORS is not a bug. It is a security feature doing exactly its job, protecting your users. And once you understand the mechanism, it clicks permanently, and you never get stuck on it again. So today we are fixing this properly. The same origin policy it is built on. What a preflight request actually is, every header that matters, and how to fix a CORS error correctly instead of with the dangerous wildcard hack. To understand CORS, you first have to understand the thing it is built on top of, the same origin policy, because CORS does not add restrictions, it relaxes them. The restriction was already there. Here is the scenario the same origin policy exists to prevent. You are logged into your bank in one browser tab. Your session cookie is sitting in the browser. In another tab, you visit some random site. Let us call it evilsite.com. Maybe you clicked a link. Maybe it was an ad. Now that evil site runs some JavaScript, and that JavaScript makes a request to your bank's API. Because your bank cookie lives in the browser, that request would carry your credentials. Without protection, evilsite.com could read your account balance or initiate a transfer, all using your logged-in session. That would be catastrophic, so browsers enforce the same origin policy. JavaScript running on one origin cannot read responses from a different origin, by default, full stop. So what exactly is an origin? An origin is the combination of three things: scheme, host, and port. Take this URL. The scheme is HTTPS, the host is app.example.com, and the port is 443, implied, because that is the default for HTTPS. Two URLs are the same origin only if all three match exactly, and watch how easily they differ. HTTPS versus HTTP, different scheme, different origin. App.example.com versus API.example.com, different host, different origin. Even a different subdomain of the same domain counts, and this trips people up constantly. Same host, but port 8080 instead of 443. Different port, different origin. It is why your dev server on port 3000 cannot call your API on port 8000 without CORS. But here is the problem. Legitimate apps need cross-origin requests all the time. Your front end on app.example.com needs to call your API on api.example.com. That is not an attack. That is normal architecture. So we need a way for a server to say, these specific origins are allowed to talk to me. And that is exactly what CORS is. CORS, Cross-Origin Resource Sharing, is an opt-in system that lets a server tell the browser which other origins are allowed to access its resources. And here is the key mental model, the one thing most developers get backwards. CORS is enforced by the browser, but configured by the server. Let me say that again, because it is the source of 90% of CORS confusion. The browser is the one blocking the request, but the server is the one that decides what is allowed. Which means your front-end JavaScript cannot fix a CORS error. You cannot disable it from the client. The server has to send the right headers, and the browser reads them and decides. The server signals its permission with a response header, And the most important one is access control allow origin. It is the server saying, I trust this origin to read my responses. The browser checks that header against the origin that made the request. Match, and your JavaScript gets the response. Missing or mismatched, and the browser blocks it. Now, not all cross-origin requests are treated the same way. The browser splits them into two categories, and understanding that split is understanding CORS. A simple request is one the browser considers safe enough to send directly, without asking permission first. A request is simple when it meets all three of these conditions. 1. The method is get, post, or head. 2. The headers are limited to a safe list, the basic ones the browser sets naturally. No custom headers. 3. The content type, if it is set at all, is one of exactly three values. Form URL encoded, multipart form data, or text plain. Why those specific conditions? Because these are exactly the requests that were already possible before CORS existed, through plain HTML forms and image tags. An HTML form could always post to any URL, so letting JavaScript do the same thing opens no new attack surface. Here is the flow. The browser sends the request directly and attaches an origin header saying who is asking. The server responds with the data, and an access control allow origin header. The browser checks, does that header match my origin? Match, and your JavaScript reads the response. No match or no header at all, and the browser blocks the read. And here is the subtle part that really matters. For a simple request, the request is actually sent. The server already did the work. That GET already ran. The browser just refuses to hand your JavaScript the response. For a read, that is usually fine. But for anything with side effects, we want to check before the request runs. And that is what Preflight is for. Any request that is not simple triggers a Preflight. The list of triggers is short, but you hit it constantly. Methods like PUT, delete, or patch. Custom headers like authorization. And a content type of application /JSON. That last one surprises a lot of developers, because almost every modern API sends JSON. So the moment you make an authenticated JSON API call, which is basically every API call, you are in Preflight territory. So what is a Preflight? Before sending the real request, the browser automatically sends a separate options request to the server, asking, I am about to send this. Is that allowed? You do not write this. You will never see it in your code. The browser sends it for you. It carries your origin, the method the real request will use, and the headers it wants to send. The server answers with its permissions, which origin is allowed, which methods, which headers, and how long this answer stays valid. The browser reads that and checks, is my origin allowed? Is put in the allowed methods? Is authorization in the allowed headers? If everything checks out, the browser then sends the real request. If not, it blocks it, and you see a CORS error in your console. And this is the key insight about Preflight. The real request, the PUT that might delete or modify data, is never sent at all if the Preflight fails. Unlike a simple request, which runs first and gets its response blocked afterwards, Preflight checks before any side effect can happen. That is why state-changing methods require it. One optimization worth knowing: access control max age. It tells the browser to cache the Preflight result, so it does not have to ask again before every single request. Without it, you Preflight on every call, doubling your request count. With it, repeat requests skip straight through. Just know that browsers cap the value. Chromium tops out at 2 hours, no matter what number you send. Let us catalog the headers you will actually work with. There are two sides: what the browser sends and what the server sends back. The browser sends these and you never set them yourself. Origin, which is who is asking. and on a preflight only, access control request method and access control request headers, describing what the real request intends to do. The server responds with these, and these are the ones you configure. Access control allow origin, which origin is allowed, either one specific origin or star for any origin. It has to match the requesting origin exactly. Access control allow methods, which HTTP methods are permitted, and access control allow headers, which request headers are permitted. Both of those only matter on a preflight response. Access control allow credentials, whether the request may carry cookies or auth credentials. This one has a critical gotcha, and it is next. Access control max age, how long the browser may cache the preflight result. And access control expose headers, which response headers your JavaScript is allowed to read. Because by default, only a small safe subset is readable, even on an allowed response. This is the single most common CORS mistake after the wildcard itself, and it deserves its own moment. When your request includes credentials, cookies, or an authorization header sent with credentials include, there is a special rule. You cannot use the wildcard star for access control. Allow origin when credentials are involved. The error reads, the value of the access control allow origin header must not be the wildcard star when the request's credentials mode is include. Why? Because star means any origin can read this. Combine that with credentials, with cookies and sessions, and it would mean any website on the internet could make authenticated requests as the logged-in user and read the response, which is precisely the attack the same origin policy exists to prevent. So the browser forbids the combination outright. The fix, when you need credentials, name the exact origin, not the wildcard. And honestly, this is good practice anyway. The wildcard is convenient in development and dangerous in production. It tells the browser that every origin on the internet may read your API responses. In production, echo back one specific origin, validated against a list you control. Let us make this practical. When you hit a CORS error, here is the correct debugging process and the correct fix. First and most important, this is a server fix, not a client fix. You cannot fix CORS in your front-end code. Stop looking there. Cause number one, and the most common of all. Your server does not handle options. You defined a route for post or PUT, so the preflight hits a 404 or a 405 and the real request never gets sent. Developers blame CORS. The bug is the missing options handler. Cause 2. A missing or wrong allow origin header. The server is not sending it at all, or it is sending an origin that does not match yours. The fix is to configure it with your front end's exact origin. Cause 3. A header mismatch. Your request sends authorization, but the server's allow headers list does not include it. The fix is to add it. So here is the wrong fix in Express. Calling the CORS middleware with no options at all allows every origin on the internet. It makes the error go away, and that is exactly what makes it dangerous. And here is the right one. Keep a list of the origins you actually trust. Check the incoming origin against that list and only then allow it. Credentials on, wildcard nowhere. One last debugging trap worth knowing. Chrome often masks a real 4xx or 5xx error as a CORS error because your server's error response does not include CORS headers either. So the console says CORS, but the actual problem is a 500 inside your handler. Always check the real status code in the network tab, not just the red text in the console. So let us bring it all together. The same origin policy is the browser's default. JavaScript on one origin cannot read responses from another. It exists to stop malicious sites making authenticated requests as you. CORS is the opt-in system that relaxes it. A server declares which origins it trusts using response headers. And critically, the browser enforces CORS, but the server configures it. You cannot fix it from the front end. Simple requests, get, post, or head with safe headers, go straight out, and the browser checks the response header after the fact. Everything else, PUT, delete, JSON bodies, custom headers, triggers a Preflight options request, which checks permission before the real request ever runs. And the fixes: handle options, send the right allow origin, list your allowed methods and headers, never pair the wildcard with credentials, and allow specific origins in production. Next time you see that red CORS error, you will not panic. You will open the Network tab, look at the Preflight, and know exactly which header is missing. Drop a comment with the worst CORS error that ever ruined a demo for you, and subscribe if you are building up your web fundamentals. See you in the next one.